that into the matrix form for the first one, what you do is, well, x, y, z. So in the ax plus by plus cz equals to k form. That's already in that form. So for the first row, I have 2, 1, 1 as the coefficient. For the second row, we have 0x, 3y, and 4z. We need the 0 there. And
this interruption. There's an amnesty for all students arriving late. We've got 3 train lines closed down this morning, or at least having delays. So just note that there's an amnesty this morning. Thank you.
We just have 4 missing. Not affected by 3 train lines. That's good. Okay, 6x, 0y, and 1z. Okay, and then we have like in order x, y, and z. That equals to -1, -7, and 8. So if you have a calculator, okay, if you have a calculator and if you want to solve it by calculator, so what you need to do is this front one inverse times by that, right? That inverse times by the back one. So what you can do, oh, well, the first one is wrong, like ignore the first one. Look at the second one. I just type this matrix in. Where you can find the matrix button is the button on the right hand side of 9, click on that, and in the middle part there's a 3 times 3 matrix. It's not only 3 times 3. When you click in it, you can change the number of rows and number of columns. Okay, and I need a 3 times 3, so I will click OK to give me that. After I put that, okay, after I type that in, I just press the power button, like the power, and put -1. So that just means inverse. And I will times by a matrix that is row 3 and column 1. Row 3 and column 1. 3 row and 1 column. Oh, sorry, I need to move it. Here, I need to move it here. So, well, anyway, row 3, column 1, and I will have start column 1. And I don't know what's wrong. Come down, please. Okay, it's here. So -1, -7, and 8. That's the answer, the k values. So I'll have x equals to 1, -5, z. So x, y, z value. Okay, that's how you solve it by a calculator. It will be quicker. Well, you can use the simultaneous equation method to solve for it. Like you can go menu 3, 1, 2, 4, solve, and click still on that button. Click on the right hand side. That I want 3 equations. I just typed. Well, the bracket should here. So you can type the 3 equation in and then move like dot, comma x, comma y, and comma z. But like it's very long. You need to type a lot of x, y, z in it. So it's very, it's more working to type it in. So this method will be easier if you can see there's a matrix and solve it by matrix. That's fine. I heard an announcement. Thank you. Oh. It is. Yeah. That's solved by matrix. So if we solve that by hand, okay, we just go one like to solve it by hand. So if we're trying to solve it by hand, we want to if you think about substitution or elimination, we want to eliminate something, or we make y in terms of x, right? Like for a whole equation, we only want the x in one equation. So in this case, we can do the similar thing. So what we can do is, let's see, we choose two easier ones. Let's see those two. Okay, we have 3y plus 4z equals to -7, and then 6x plus z equals to 8. Let's say that's equation 1, 2, and 3. You can choose any two to start. Okay, what I want to do, I want to represent y in terms of x and z in terms of x, or x in terms of y, z in terms of y. I want to make the other two all in terms of one thing, and then sub that into one equation, trying to solve for it. So for example, I think those 2 and 3 are easy to calculate. So I will times equation number 3 by 4 to give me 24x plus 4z equals to 32. Okay, let's say that's equation number 4. So I will put 24 plus 0y plus 4z equals to 32. That's number 4. And I'll use number 4 to subtract number 2. So number 2 is 0x plus 3y plus 4z equals to minus 7. That's number 2. So I use 4 to subtract 2. What I'll have is 24x minus 3y equals to minus those two equals to 39. So I can divide by 3. 8x minus y equals to 13. So y equals to 8x minus 13. Okay, that's y. Y equals to 8x minus 13. Move y to right hand side and 13 to left hand side. Let's say that's number 5. Okay, y is in terms of x now. What I want to do, I want to make x in terms of z in terms of x as well. So I will sub number 5 into number 2, because that's where you have y and, well, I don't need to sub it. I can go for from number 3. What I can see is z equals to minus 6x plus 8. I don't even need to do anything. From the third one, we have relationship between z and x. Okay, z equals to minus 6x plus 8. What all I want to do is make y in terms of x and z in terms of x. Okay, this one can directly give me z in terms of x. And the second one can show me, well, I can do y in terms of z and then y in terms of x, or do like what I did. Eliminate the z and we only have relationship between x and y. There's more than one way to do it. For 3 variables, 3 equations, there's so many ways to do it. You can use any 2 equations to make the relationship. So now what we have is, I will sub number 5 and 6 into number 1, because we haven't used equation number 1 yet. We'll sub that into equation number 1. We have 2x plus y. Y is 8x minus 13 plus z. Z is minus 6x plus 8. That equals to negative 1. So we have 10x minus 6x. We have a 4x minus 13 plus 8. We have a minus 5 equals to minus 1. 4x equals to a 4. X equals to 1. Check, yes, x is 1. So therefore y will be 8 times 1 minus 13. Y will be minus 5. And z is minus 6 plus 8. Z is 2. Yep, that's exactly the same as the calculator's answer. This question, like this simultaneous equations, are easy questions, because for the second one, third one, we just have relationship between y and z and x and z. So it's like reduced a lot of like calculations here. So if you think about example 2, that will be much easier, much harder compared to the first example. After you finish this one, you can have a try of the second one. What you want to do is trying to use 2 equations, trying to eliminate or substitution to make y in terms of x and z in terms of x. Or if you want to make x in terms of y and z in terms of y, that's also fine. So you just make 2 other variables in terms of like the first variable. That's it. For example 2, I would say eliminate x first. Like it will be much easier to eliminate x. You can use the first 2 equations to eliminate x. Then you can either put y in terms of z or z in terms of y. Okay, so what I've done to this question is I'll add equation 1 and equation 2. We have 5y plus 5z equals to 15. So y plus z is a 3. I divide 5 on both sides of the equation. And I can say z is just minus y plus 3. Then my z will become y now. I will sub that in either equation 1 or equation 2. Well, I don't want to use equation 3 because I want to sub both x in terms of y and z in terms of y into equation 3. That's the last equation I want to use. So I will just choose 1 or 2 to substitute. So I substitute the new equation into number 1. I have x plus 2y plus 3z, but your z become y now. So it's 3 minus y plus 3 have 13. Rearrange this equation, simplify, you have x minus y equals to 4. Therefore, x equals to y plus 4. Then we have z in terms of x, y, and x in terms of y. We will sub both equations into the last equation, which one we haven't used before. Well, if you use 2 and 3, then just sub into the first one. If you use 1 and 3, then sub into the second one. So sub into equation you haven't used yet. So I have minus bracket y plus 4 minus 4y plus 7z, z is minus y plus 3, equals to 17. Expand the bracket, rearrange it, what you have is y equals to 0, because it's minus 12y plus 17 equals to 17. Your y just 0. So x is 4 and y is 3. That's how we solve for it. Any questions? There's more than one way to solve for it. You can use other way to do it. At least you need to know how to write the matrix. Okay, that's the minimum requirement. You need to know how to write the matrix, how to solve the matrix on the calculator. Okay, and you know, like if I write the equation in the order of 1, 2, 3, my matrix will look like 1, 2, 3, minus 1, 3, 2, minus 1, minus 4, and 7. Then x, y, z equals to 13, 2, and 17. I can also write in the way like minus 1, 3, 2, 1, 2, 3, minus 1, minus 4, 7. X, y, z equals to 2, 13, and 17. Can you see what I have done? They are all represent the same matrix for this question. What I'm doing, just swap the second row all together with the first row. Okay, I swap the order of first row and second row, which means your equation 1 and equation 2 change order. Okay, that becomes your equation 1, that becomes your equation 2. So they are the same thing. The multiple choice I see in the VCA exam, they always swap the order. They never really give you in the order like they give you. They always swap something. And some of the questions, they will swap only the left-hand side, but they didn't swap the right-hand side, which is wrong. If you want to swap it, you need to swap all together with the whole row, like movement, like with the, like including the k value, you need to move that as well. So the trap will be they're not moving the k value, but moving the left-hand side, the coefficient, which is wrong. But if you move the whole line, then both this and this, they are both correct. Any questions for 3 simultaneous linear equations? Okay, if no, we go in some extensions. Okay, we're going to see some extensions, which is 3 simultaneous equation, what that means. So for 3 simultaneous equation, they represent like, it's not 2 dimension, it's 3 dimension, it's a plane. You have 3 planes to intersect. So the first one, like 3 things intersect that way, you have 1 intersection. Diagram 2, it represents like a line, there will be infinite many solutions. For 3, they're all parallel to each other, which means there's no intersection. Interesting is like number 4. This one is intersects with this 2, but there's still no solution because they're not intersects at the same point. Even though plane 1 and plane 2 intersects, plane 1 and plane 3 intersects, but 2 and 3 is not, there's no intersection between them. So there's no solution in this case. And that one is no solution case as well. There's more than one way you can have no solutions. Okay, there's more than one way you can have no solutions. They can intersect. Well, if it's three plane, they can not intersect in so many ways. So these are just some of the situations listed out. But you don't need to think about the graph. It's very hard to think about the graph. Also, you don't know what's the degree of the plane like they meet, or like something like you can't draw XYZ graph yet. So what you do, you will think that, so this question is very similar. Okay, this question is very similar to the question we learned yesterday. Okay, the 2 times 2 simultaneous equation. We find the k value will give me no solution, one solution, and infinite many solution. So it's 3 times 3. What we can do to 3 times 3 equation, and we want to see the n value to see whether I have no solution or infinite many solution. So I need to reduce a 3 times 3 equation into a 2 simultaneous equation. I need to reduce it to 2 equations. Well, I don't want to see x, y, z. I want 2 equations with only 2 variables. I want 2 equations with 2 variables. I don't want 3 equations with 3 variables. I want reduce it to 2 equations with 2 variables. I'll tell you why in a minute. Let's do that first. In these 3 equations, is there any equation you can see we will keep it? Yes? Will you keep anything like as it? We are not changing it. Like, want to satisfy 2 equations, 2 variables. Which one you will just leave as that? 2. Can you see that? We'll leave 2. Because in 2 we only have y, z. Okay, there's only 2 variables in the second equation. That's why I will keep it. If like you still have 3 variables in the second one, we need to change all of it to make it to 2 equations, 2 variables. But because the second one is already got 2 equations, 2 variables in it, we will just keep it like that. We are not changing it. We are not touching it. So what I will do is reduce 3 variables to 2 variables for 1 and 3. We don't want x. Therefore, we don't want x because the second one got y and z in it. So for the first one, third one, I want to get rid of the x. Okay, so that's why I want to get rid of x. So I will times equation number 3 by 2. That gives me 2x minus 4y plus 2z equals to 2. The second one is 2x plus n plus 3y minus n plus 4z equals to 1. That's it, that's equation number 4. I want to get rid of x, therefore I will use equation number 2 to subtract the equation number 4. You have 2x, 2x, I will subtract that. So 2x, 2x, you subtract that. n plus 3y minus negative 4y minus n plus 4z minus 2z equals to minus 1. Okay, so 2x and 2x now, n plus 3y minus the negative 4y equals to minus blah blah blah. Z equals to 1 minus 2, which is negative 1. So just subtract them and rearrange that. Therefore, we have n plus 7y minus n plus 6z. Well, here, it's a little bit confusing here. It's a minus nz minus 4z minus 2z. Therefore, it's minus nz minus 6z. That's a minus n plus 6z. Okay, so minus n plus 6z. So minus z bracket n plus 6. So it's minus n plus 6z equals to minus 1. Let's say that's equation number 5. Okay, I will repeat equation number 2. Well, I will keep this coefficient as plus, minus, and minus 6. Maybe that's easier to see. We have that m plus 4z equals to 2. That's the equation number 2. Okay, we'll use those two equations now. That is back to the original question, like what we learned yesterday. We have two variables, two simultaneous equations. There are 3 situations for that. We have no solution, unique solution, and infinite many solution. Okay, if we have unique solution for y and z, I will definitely have unique solution for x. Is that right? If we have a unique solution for y and z in these two simultaneous equations, I will definitely have a unique solution for x, right? Because I will sub, for example, y equals to 1, z equals to 2. I will definitely sub into that one. Y equals to 2, x equals to 1, and then solve for z. I can definitely solve out z. It's just a linear equation. If z and x, y and z have infinite many solutions, my x will also have infinite many solutions. Because I have infinite many pairs trying to substitute into the first one, and I'm solving for x, I can have infinite many x values. If I have no solution between y and z, which means I will definitely have no solutions for x as well. So it's exactly the same as the 2 times 2 simultaneous equation. Because the third one is just by substitute the x and y and z back into the original equation to solve for another x. But because it's a linear equation, if I have unique for y and z, I will definitely have unique for x. If I have no solution for y and z, I won't have x. If I have infinite many pairs of y and z, I will definitely have correspondingly infinite many pairs of x as well. So the question back to the original type is back to what we're familiar with. Therefore, using the method we see yesterday, we have n plus 7, 2, minus n minus 6, and n plus 4 times y and z equals to minus 1 and 2. Again, we are trying to solve for matrix. Okay, if we're trying to solve for matrix, what we need to do is think about the determinant. Okay, think about the determinant. So determinant of this matrix equals to n plus 7 times n plus 4 minus 2 times minus n minus 6. I'll expand it. N squared plus, well, 7n and 4n, 11n, 28 plus 2n plus 12. N squared plus 13n plus 40. And that's n plus 8 and n plus 5. That's the determinant. Okay, between the y and z. Between the y and z. What all I have done is reduce the 3 simultaneous equations into 2 variables, 2 simultaneous. And I'm trying to think from what we know already. We have 2 simultaneous equations. If we have unique, we will definitely have a unique solution for x. If we have infinite many, we will have definitely infinite many corresponding pairs of x. You have no solution between those two, I have no solutions for x as well. So it's exactly the same as 2 times 2 equations. So what I will do is determinant equals to 0. We have n equals to minus 8 and n equals to minus 5. So for unique, we will have n belongs to R except minus 8 and minus 5. Because if determinant is not 0, I can easily solve out y and z. Therefore, I'll have a unique x as well. Okay, that's for last lesson what we learned. So definitely not those two. Any other value is fine. So now I will see if n equals to minus 8. My matrix will become, well, sub into that one. Minus 1, 2, 2, minus 4, y, z, minus 1 and 2. From here, go here is times by negative 2, same as this, and same as this. They are the same equation. So this one is infinitely many solution. Okay, infinitely many solution. If n equals to, another problem point is minus 5. If n is minus 5, okay, again, still sub into that one. 2, 2, 1, minus, 2, minus 1. Y, Z. Oh, that's a minus 1 as well. Minus 5, minus 5 is 5. 5 minus 6 is a minus 1. And then we have minus 1 and 2. Well, you can see this is times by 1. Okay, the coefficient is times by 1. But that one is times by negative 2, which is not working. So this is not the same equation. Therefore, n equals to minus 5. There's no solution. There's no solution between y and z. Therefore, there's no solution between x, y, and z. Okay, there's one question asking, state the solution of in terms of a parameter t in this case. Because we have infinitely many solutions, we want to use a parameter t to represent all the solutions. So what are these solutions? It can't be random numbers. It can't be any number in the Cartesian plane. So we need to follow a particular set of numbers. So therefore, because we know when n equals to negative 8, we'll have infinitely many solutions. We'll say when n equals to minus 8. Okay, according to this matrix, we have minus y plus 2z equals to minus 1. Okay, minus y plus 2z equals to minus 1. So what I will have here is it was, I'll say y equals to 2z plus 1. Okay, y equals to 2z plus 1. And let's look at the first equation. Also, from equation number 3, we know x equals to, let's make it smaller. From equation number 1, we know x equals to 1 plus 2y plus a minus z. Okay, from number 3, we can see x equals to 2y minus z plus 1, like this. So x equals to 2y. 2y is 2 times 2z plus 1 minus z and then plus 1. So x equals to 4z plus 2 minus z plus 1. X equals to 3z plus 3. Okay, so what we have is y in terms of z and x in terms of z. So what I will say is, let t be any value. Let parameter t. So let z equals to t. T belongs to R. Okay, z is anything. Okay, z is anything. Therefore, your y value must be 2t plus 1. And your x value must be 3t plus 3. Therefore, the answer is this. Okay, t just be anything. If you change the value of z, your x just be 3 times of that value plus 3. And then your y will be 2 times of that value plus 1. So it really depends on the z value. So, but z can be anything. Z can take anything. So when z take a number, I will change my x and y correspondingly to fit like the requirement. So that's why I put x and y in terms of t. Well, if you like, you can put z and y in terms of x. That's fine as well. Therefore, just say x can be anything. X will be t, and then see what is like the other two. So it's a lot of ways to write about this, but this is how to use a parameter to represent that. So t just means anything. T belongs to R. Therefore, y and x needs to change correspondingly to fit the requirements of the whole set of simultaneous equations. This is a very hard question, but like it involves a lot of thinking, which is really good training to think back of like our 2 times 2 simultaneous equations. Why we reduce into 2 variables, 2 equations, because we want to find a way we're familiar with to solve for things. It will become more and more important for VC exam now, how you can deal with unfamiliar situation. Okay, how do you change an unfamiliar situation into something you already learned? So that's a really good example. Okay, I don't know anything about 3 times 3 simultaneous equation, whether they have one solution or unique solution. I can't think about the graph, but I know we can reduce it. We can reduce into 2 times 2 simultaneous. Therefore, we can solve it by this way. And you can think, if we have unique for x and y, I must have unique for z as well. If I have no solution for the other two, I will definitely have no solution for this whole simultaneous. If I have infinite many for x and y, there will be infinite many pairs of x to fit this requirement. So therefore, it's back to the original situation. So we have done chapter 2 here. Okay, that's everything. I'll upload the solution for you, and you need to catch up any work you haven't done yet. Next Tuesday is the quiz, chapter 1 2 quiz. I think it's no cast, no notes. Next Wednesday is swimming, but next Thursday we'll do transformation. Okay, it's another important topic, and this is like the worst topic I feel students feel like they don't really understand what's transformation. So we'll go through that one as well.